Okay, I think we can start first for this one. Okay, so let's look at the questions from the complex numbers. Okay, the first question here, given that we have got a series C and S, okay, are defined by this, okay, and first we need to show that for the C plus IS, okay, it is equals to 3 e power 3I theta minus e negative 3I theta and so on. Okay, so for this one, okay, we have to first look at the terms, okay, inside the C and S. So for C, it would be 1 plus cos theta and 2 theta and so on. So we know that it is going to be the sum of the cos of the multiples of the theta. Okay, and from there, we will actually have the C here is actually equals to the sum of the cos r theta, and the values of r goes from 0 to 5, because we know that for when r equals to 0, we have cos 0. So cos 0 gives us a 1. So this is why we have got this 1 here. Okay. As for the sine, okay, although we only have 5 terms there, which is from sine theta to sine 5 theta, because we want to ensure the consistency with the cos, we will actually have to add in the terms which is when we have 0. So we know that sine 0 is a 0. So this is why in the sum, we actually start with the r is equals to 0. So we are summing for r equals to 0 to 5 for the sine r theta. So it means we start with sine 0 and plus sine theta and so on until we have got the sine 5 theta. Okay, so this is when we actually look at them separately, and when we actually add them together, which we have got the cos plus I sine theta. So this is to actually sum them together. So we have got cos theta plus I sine r theta. For this one, if we actually write them in the exponent form, so it will be e to the power of I r theta. Okay, so the sum here is from r equals to 0 to 5. So again, what do I mean by sum from r equals to 0 to 5 for this e power I r theta is that we are summing actually from e power 0, which is 1, plus e power I theta, and so on, until we have got e power I of 5 theta. Okay, so this is what we are actually trying to sum. And from there, we actually use the formula for the GP, the sum of our GP. So in this case, the R, okay, is the e power I theta. So this is our R. And then we have got N. N is our power number of terms. Okay, so in this case, we actually have got 6 terms here. So this is why our power here is a 6. So when we actually expand this one, we actually have e power 6I theta minus 1. And we have got e power I theta minus 1 as a denominator. So from there, okay, what we do is we actually try to factorize out, okay, some terms from the numerator and the denominator respectively. That is the easiest way that we actually go to the result. So what we do is from the numerator, okay, we factorize out e power 3I theta. So this is why we have got 3I theta and minus e power negative 3I theta, since we actually factorize out the e power 3I theta. And do the similar thing for the denominator. For denominator, we factorize out the e power half I theta. Okay, so with that, for these two terms that we actually have factorized out, we will actually have the power is e power 5 over 2 I theta. Okay, so from that, this is basically what we need to prove from the question. All right, so sorry, my program is freezing again. Okay, so this is okay, let's look at this one again. So for C and S, okay, there will be this expression. Okay, and for C plus IS is we add them together. Okay, and after we add them together, we will actually have an e power IR theta. Okay, we're actually trying to sum this. And for that, okay, because we are adding from 0 to 5, okay, we have got 6 terms of that. So So this is why we actually use the formula for the GP. Okay, and this for this formula, the GP, we actually will end up with the e power 6 I theta and e power I theta. So later what we do is we factorize the suitable terms from there. Okay, for the numerator, we factorize out the e power 3 I theta, and for the denominator, we factorize out e power half I theta. And from there, the two terms will actually cancel off. It will become e power 5 over 2 I theta. And for this chunk of expression is what we really need from the question. Okay, so this is what we need to do for the first part. Okay. So for the second part, okay, what we need to do is we actually need to find an expression for C, okay, and prove that C is given by the expression, okay, in the question. So for part 2 is by looking at the C plus IS together, okay, because from what we have got earlier on in the expression, so for this numerator, okay, from this expression we know that this is 2i sine 3 theta. So likewise for the denominator is 2i sine half theta. And then for this one, okay, this one is from the e power 5 over 2i theta. So e power 5 over 2i theta is our cos 5 over 2 theta plus I sine 5 over 2 theta. Okay, and from there, because we only because the this one 2i, we can actually cancel them off. So this is the expression for our C plus IS. And how do we deduce that the C is given by the one is for C, because it's the real part, okay? C here, okay, it's just the real part of the number. So we are only looking at the real part, okay, from the right hand side. So the real part of the right hand side is looking at this one, the cos, to multiply with this expression here. Okay, so this is why we have got this expression, and just have to move the sine half theta up, then we'll actually get cosecant half theta. Okay, so likewise for the expression for S, the S is here the imaginary part. So instead of taking the cos, now we are taking the sine, okay, from the imaginary part, and then we multiply with this number again. Okay, so this is why we actually get a similar expression from the first line there lah. Okay, so that would be for the second part. Okay, and for the third part, okay, is to find the value for the theta, okay, in the range of 0 to pi, for which when we have the C is equal to S. So from that case, right, okay, we have got this, when we have C is equal to S, okay, when we actually try to solve that, right, it is not about, because we have got, when we actually equate the C and the S together, we have got some common terms here, which is sine 3 theta and cosec half theta. So we are not supposed to cancel them before we actually rearrange. So what we need to do is, we need to factorize the two terms, like, okay, when we actually try to solve it. So from there, okay, we actually have to solve each one separately. So for first one, we have got sine 3 theta. So for this, we have got sine 3 theta is equal to 0, and we just have to solve from there accordingly. Remember, we have got the range for the theta is from 0 to pi, and pi here is not inclusive. Okay, so this is why we have got these three values here. And for the second one, cosecant half theta, there is no solution to it. Okay, we cannot have the cosecant is a 0 lah. Okay, for the value. And for the last part, we have got sine 5 over 2 theta minus cos 5 over 2 theta is equal to 0. So by rearranging, we will actually get this tangent 5 over 2 theta is equal to 1. And just solve for the 5 over 2 theta, okay, following this, okay, range here, okay, to make sure we actually cover all the values that we have we actually need. And we, from there, okay, we actually get the theta is these three values. Okay, so this is why from there we actually have got these 6 values for our theta. Okay, so next one. So okay, first part, verify, okay, without using a calculator, okay, that theta equals to 1 over 8 pi is a solution of the equation sine 6 theta is equal to sine 2 theta. So from there, because it says it's a verify and it's only 1 mark, so basically we just have to substitute the theta Okay, inside the values for the sine lah. So we have got sine 6/8 pi, which is sine 3/4 pi. It is just equals to sine 1/4 pi. Okay, so basically just substitute in and say they are equal. Basically the verifying word is just like that. Okay, and next one, okay, by sketching the graph of y is equals to sine 6 theta and y is equals to sine 2 theta in between 0 to half pi. So find the solutions of the equation sine 6 theta equals to sine 2 theta in this interval. So before this, okay, we have already verified. Okay, one of the solution is 1/8 pi. Okay, we need to find out what is another solution from that. So basically is to sketch the graph for sine 2 theta and sine 6 theta. So of course for this one we know how to sketch, okay, by looking at the 2 theta and the sine 6 theta, okay, we know how to sketch the graph. So what we actually see from there is we actually have different intersection. So we have got intersection at 0 and pi/2. Okay, this is of course something that we know, and then the question do not want it because the question wants this. Okay, you see there is no equal sign from there, so they don't want to look at the intersection for 0 and half pi. Okay, so we actually have another value from there. So knowing that, okay, from the part A, we already know that one of the intersection or their solution or their root, okay, whatsoever, their one of the value here is 1/8 pi. Okay, so this is one of the value that we know. So from there, we actually know there is another intersection here. Okay, so for this intersection, the value will be 7/8 pi. Okay, so why do we actually know about this one is by looking at the symmetry property. Okay, so when we actually look at the symmetry property, this value here should be 7/8 pi, okay, from the graph. Sorry, this one is not 7/8 pi because here is a pi/2, so this one should be pi/2 minus 1/8 pi. Okay, so for this one should be a 3/8 pi. Okay, sorry about that. The value should be 3/8 pi. Okay, because this one is a pi/2. You know the idea, right? So from here to here is the distance is 1/8 pi. So from here to here it should be also 1/8 pi because they are symmetrical over here. Okay, so it should be 3/8 pi, not 7/8 pi. Okay, so that is for 1B. Okay, second one. So the use the Morse theorem to prove we have got sine 6 theta is equals to sine 2 theta multiplied by this equation. So from there, okay, what we need to do is we always have to use the binomial expansion, okay, in order for us to find the value for the cos n theta and the sin n theta. So we start with expanding, okay, the cos theta plus I sin theta, in this case to the power of 6. Okay, so from there, okay, we just expand everything, okay, from here, and then we just collect the real part, okay, and this is our imaginary part. Okay, so for this one, okay, we want to look at the value for the sine 6 theta. Okay, so for sine 6 theta is basically the imaginary part of that. So by looking at the imaginary part, okay, which we have it here, okay, so the first thing that we can do is we can actually factorize out 2 cos theta sine theta from all the terms there. Okay, it is good for us to proceed from there. So these 2 sine theta cos theta will give us sine 2 theta, okay, as what is needed in the question. And from there, okay, we have to deal with the sine squared and the sine power 4 here. Okay, so in order for us to deal with the sine squared and the sine power 4 there, it's just we use the 1 minus cos squared. for the expression for the sine square, okay, and then we just have to expand from there, and from that, okay, we will actually be able to get what is required to prove lah, okay. So that would be for the second part, all right. So for the third part, okay, let's look at the question. So hence show that one of the equation obtained in part 1 satisfy cos squared theta is equals to 14 times 2 minus root 2 and justify which solution it is. Okay, so how do we actually get this kind of the thing is that, okay, because this one is actually the value for the cos squared theta. Okay, so what is the clue that we can actually get from this cos squared theta is that the cos squared theta must come from here lah, because this one it is a quadratic equation which is in terms of the cos squared theta. Okay, so the value must come from there. And then what we actually have proven, okay, earlier on is that we have already proven for sine 6 theta is equals to sine 2 theta. Okay, so in that case, when we actually move this sine 2 theta down, so when we have sine 6 theta is equal to sine 2 theta, so it means when we move this down, this whole thing should be equal to 0, equals to 1. So this is what we have for this 1. Okay, so if this is equals to 1, so it means that the quadratic equation is also equals to 1, okay, based on the sine 6 theta is equals to sine 2 theta. Okay, so in that case, we will actually have, because we have already let the sine 6 theta over sine 2 theta is equals to 1, so the 16 cos power 4 theta, that quadratic equation should be also equals to 1. So both of them should be the same. Okay, so what does that mean? It means the value of theta which satisfies this equation, which is sine 6 theta equals to sine 2 theta, should also satisfy this equation. Okay, so from there, from the first equation that we have there, we know two of the roots would be 1 over 8 pi and 7 over 8 pi. So they are two values, okay, which is also satisfy, which will also satisfy this equation. Okay, so from there, okay, this is a quadratic equation, right? So we just have to solve, okay, from this quadratic equation. And from there, what we actually have is we actually have this quadratic equation. When we actually try to solve, we have got the cos squared theta is equals to this value, okay, 1 over 4, 2 plus minus root 2. Okay, so from there, because, okay, now we know that we have got, this is 3, from the earlier mistake there. Okay, so for this one we have got 1 over 8 pi and 3 over 8 pi. Okay, which one should we take for the value for the 1 over 4 2 plus root 2? So if we look at the question, they need us to find out, okay, which one, which of the theta satisfy these 2 minus and 2 plus. So for that one, we have got two values, right? So one is cos squared theta is equals to 1 over 4, 2 plus root 2, and another one is 2 minus root 2. Okay, and then we have got two values of the theta that we need to fill in. Okay, our theta is 1 over 8 pi and 3 over 8 pi. So we just have to fill in this one. And we need to we need to give a little bit of explanation why. Okay, we'll actually fill in this one. So for the first one, because it's 2 plus, it has a larger value. So for the larger value, okay, it will actually belongs to the 1 over 8 pi. Okay, for the second value, 2 minus root 2 is a smaller value, so we will actually give it to the 3 over 8 pi. Okay, because remember in the first cycle when we have the pi over 2, the value of the cos goes like this. So that's for the cos square. So the smaller the theta that we have, the cos square theta will actually have a larger value. Okay, so this would be for the 1 over 8 pi, this would be for the 3 over 8 pi. Okay, so this is why we actually take the 1 over 8 pi for the plus, and for the 3 over 8 pi, okay, to be the smaller one, which is the negative Okay, 2 minus root 2 for that one. Okay, so that would be for the second question here. Okay, next one. Okay, so first, okay, by expressing sine theta in terms of e power I theta and e power negative I theta, so show that sine power 6 theta is this. Okay, so basically this one starts with the definition for the sine theta. Okay, so the definition for the sine theta, we know that it is 1 over 2i multiplied by e power I theta minus e power negative I theta. And then now what we need is we need to have 6, okay, as the power. So basically we just have to power 6 the whole thing from this right hand side here. And this is what we get. For the 2i, okay, when we actually power 6 to it, we will actually get negative 64. Okay, so be careful of the plus minus sign from there. So as for this one, e power I theta minus e power negative I theta to the power of 6, we need to expand it. Okay, so when we actually expand it, okay, we actually have this, okay, this whole thing, this whole bunch of thing. And next thing that we need to do is we just have to collect all the similar powers together. So we can see here we have got the 6, 4, and 2, and also the constant term here lah. So just collect the 6 and the negative 6 together, 4 and the negative 4 together, and then we'll actually have this nice expressions here. Okay, so from there, we know that again, okay, we have got this result that if we have e power I theta plus e power negative I theta, it should gives us a 2 cos theta. So in this case, we have got all the 6 thetas, 4 thetas, okay, and then they are plus together with the negative power. So that will actually gives us a 2 cos 6 theta, 2 cos 4 theta, okay, and also we have got 2 cos 2 theta from there. Okay, and then after that, just tidy up a little bit from there. Okay, then we will actually get what we need to prove lah, okay, in the first part. Okay, so that would be for the first one. Okay, second one, replace theta by half pi minus theta, okay, in the identity in the part 1 to obtain a similar identity for cos power 6 theta. So for that one, right, for this one, okay, for the left hand side, if we substitute the theta with pi over 2 minus theta, we will actually get a cos theta, because we know that sine of pi over 2 minus theta is equals to cos theta. So if we power 6, it's just power 6, okay, no difference from there. So if we actually substituted the pi over 2 minus theta into the left hand side, we should, okay, do the same thing to all the right hand side as well. So all the right hand side, we should actually have all this kind of the expression, okay, and from there, okay, if you are not sure what are we actually getting, we can always use the compound angle formula. So this is the formula for like cos A minus B. So just use cos A cos B plus sin A sin B for that. Okay, so this is when we actually use cos A cos B plus sin A sin B. So I ignore all the terms for the sine because we have got all the multiples of the pi. So in the sine, it will be 0. Okay, you can actually write them out to be clear, but I didn't write it out because I know they are going to be 0. Okay, so basically is you use the compound angle formula. So from there, it actually gives us the positive and the negative sign of the terms. So because we have got like cos 3 pi, cos 2 pi, and a cos pi, so it's time for us to decide, okay, what are the values for the cos 3 pi, 2 pi, and pi. Basically, they are actually just 1 or negative 1 from there. Okay, so at last, what are we actually getting is that we will actually have 1 over 32, and inside there, all the terms will become positive. Okay, so this is what we get from the cos power 6 theta. Okay, so that is what we get lah for the part 2. Okay, so next one, we need to find the integral of this, okay, sine power 6 minus cos power 6 from 0 to 1 over 4 pi. So basically, we have got the expression for sine power 6 and cos power 6, and then a lot of terms, they will actually cancel off each other, okay, because of the plus and minuses. Just work with the plus and minuses carefully, okay, and then this is what we actually get lah from there. Okay, so for that, okay, we actually have to integrate, okay, this term. So what I did was actually factorize out the negative 1 over 16, and I will just have to integrate the cos 6 theta and the cos 2 theta from that. So after that, integrating is not difficult for us to do, and then substitute the values for the 1 over 4 pi and the 0 inside and evaluate, and we should be able to get this value. Okay, the integrating one shouldn't be difficult to do lah. All right. Okay, next question. So solve the equation cos 6 theta is equals to 0 from 0 to pi. Okay, so for this one, I guess we all can do as long as we cover all the values that we need for the 6 theta lah. Okay, our theta goes from 0 to pi. So from there, we actually get the theta is in the form of k pi over 12. Okay, for which our k is from 1 to 11. Okay, for this like 1, 3, 5, 7, 9, 11 lah. Okay, so this one shouldn't be difficult to do. So for the second part, okay, for the second part, we have got the cos 6 theta is equals to this expression. Okay, for this one, it's the similar thing that we have done before in the previous part. So instead of looking at the imaginary part, we look at the real part. Okay, so this one we don't have to do another round because we have got the same thing before this already. Okay, so if we now consider the real part instead of the imaginary part, so what we need to deal with is we have to deal with the sign. Okay, we have got sine power 2, power 4, and power 6. So for that, we just have to use the 1 minus cos square. Okay, so for the 1 minus cos square, okay, we we just have to use the identity and to get all the identities that we use. Okay, we actually end up with the expression which only has all the cos lah. Okay, so at last we will actually have this expression. Okay, so from there, okay, it's either we actually end up with this expression, or somewhere in the middle we can actually see the pattern from there. But for this one, because we want to factorize this into something which is like not so obvious for us to look at. Okay, so we have like 2 cos square minus 1. We have to factorize that into something that looks like that. So just try to write our expressions that we have, okay, here, this one, to something that has like 16 cos power 4, 16 cos square, and 1. Just try to write it something in terms like that by splitting the coefficients of all this. Okay, so by splitting the coefficients and trying to write it in this form, then only we can say that we factorize out this thing, okay, in the bracket, and before that it will actually end up with 2 cos squared theta minus 1. Okay, just trying to do something from there, try to factorize, okay, and give what the question requires lah. Okay, just try to rewrite that. Okay, so that will be for the second part. Okay, so okay, if we look at the question again for the third part, so hence find the exact value of all this. So we have got, you see here, we've got 1, 5, 7, and 11. So and then this, okay, actually comes from all this, okay, cos 6 theta and also the cos 6 theta equals to 0. So they are actually all related. So okay, so what does that mean is, okay, for the first part we did cos 6 theta is equals to 0, and we have got some roots. So in the second part we have already proven that, okay, cos 6 theta can be also written in this form. Okay, so it means when we actually want to prove this one, which is in the third part, right, we will actually have to equate this to be 0. So if cos 6 theta is equals to 0, this one is also equals to 0. Okay, so what does that mean? It means the 6 values for the data that we have got from here, okay, will also be the 6 values of the data that satisfy this equation. Okay, because when we actually try to expand here, they are actually cos power 6. So we should have 6 values for the theta, which is the root, which will become the root of this equation. Okay, but if we actually look at this one here, we only have 4 roots. Okay, because from previous part, we know that we have got 6 roots, right? But here we only have 4 roots. So where does this 4 roots comes from? They are actually from here, because this is an equation which has a power 4. Okay, so there are actually 2 roots that we have to ignore, okay, from the previous part, okay, that we need it to prove for this part, okay, for part 3. So from there, what we have is, if we actually look at, there are 2 parts of the equation, right? So if we actually look at the first part of the equation, if we make it to be 0, so when we actually solve from there, we actually have 2 values, which is 3 and 9 pi over 12. Okay, so before this, remember we have got 1, 3, 5, 7, 9, 11 for our theta, okay, which is the k equals to this one, and for our theta, we have got the theta is k pi over 12. Okay, so because the 3 and the 9 theta belongs to this one, so we are not going to look at them already. Okay, so the rest of the values, which we have 1, 5, 7, and 11, would be the roots for this equation here. Okay, so this is why we have got the roots for all this will be all the cos of the cos of the k pi over 12. Okay, so and lastly, okay, how do we actually prove this one? This is basically the product of all the roots, which is alpha, beta, gamma, delta. Okay, so this is basically by looking at the equation, we just have to use the alpha, beta, gamma, delta here is E over A. So our E is 1, the A is a 16. Okay, they are the product of the root. So from there, these values, when we actually multiply them together, it will become 1 over 60. Okay, so this is how we actually do this part 3. So next one. So for this series, okay, convergent infinite series, okay, is defined by this, okay, 1 plus 1 over 2 cos theta for C, and then for S it will be half sine theta, 1 over 4 sine 2 theta, and so on. So for this one, the idea is very similar to what we have done before. So with that, okay, it is easier if we actually establish a series for the C and S. So by looking at the first one, we have got C here. So for this C, right, okay, because it starts with a 1, and then we see that here the coefficients are actually the multiples are half. Okay, so it means we can actually put the 2 in the denominator, and then we keep increase the power, okay, when we actually have the following term. So this is why the 2r comes below there. Okay, or if you want to use like 1 over 2 power r cos r theta, also the same thing basically. So for that one, the r starts from 0, so this is why we have got a 1, and when r equals to 1, we have 2 power 1, which we have 1 over 2, okay, in the term. So this one is an infinite series, so this one actually sums to infinity. Okay, and for S is the same thing, although there is no term here, but to ensure that we have got the same values for the R here from 0 to infinity, we actually force ourselves to start with R is equals to 0. So when we have R is equals to 0, although we have got this one when 2 power 0 is a 1 here, but for this one is actually a 0, which gives us a 0 here. Okay, so this is how we actually form the sum for the C and the S from there. And after that, okay, we actually see that we can actually add the C plus IS together. So when we actually add them together, the numerator actually gives us a complex number. So cos theta plus I sine r theta, which we can actually write them in the exponent form. So in the exponent form, it will be e power ri theta. And for this one, the denominator still the same, which we have 2r. Okay, so for this one, it's a sum of a GP, but this one, it's sum to infinity of a GP. Okay, so for this sum to infinity of a GP, we have got a over 1 minus r. Okay, so we have got the a here. The a is the 1 when we have r is equals to 0. So the r here is a half e power I theta. Okay, from there we can actually see this is our r lah. And I just have to tidy out a little bit. So we have got 2 over 2 minus e power I theta. Okay, so that is what we need to prove from that. Okay. So if you look at part 2, so hence show that C is equal to this expression. So before we actually look at whether C and S, because we still have to get both of them at the same time. So what we do from there is we just have to tidy a little bit for the 2 minus e power I theta. Okay, for this one, we have got 2 minus e power I theta, for which we have complex number in the denominator, which is like most of the time we do not like it. So from there, okay, we have to multiply with the conjugate. So in this case, the conjugate is not 2 plus e power I theta. Okay, this is not our conjugate. We won't end up with something nice. So the conjugate is, in this case, is we have to negative the angle, okay, for this number, okay, I theta, we have to negative it. So this is why we have to multiply with the 2 minus e power negative, okay, I theta from there. So after we actually multiply that, okay, the numerator, okay, is very easy to handle. So just leave it as that one. And for the denominator, right, once we actually try to expand this two term, okay, we actually have some nice thing inside. So we'll actually end up with something which is like negative 2 in the bracket, e I theta plus e negative I theta. So from here we know that for e power I theta plus e power negative I theta, this one is a 2 cos theta. Okay, it's a nice result. So just tidy up the denominator from there, okay, and then we will get 5 minus 4 cos theta. Okay, numerator, just have to write out this, okay, e power negative I theta in the polar form. So be careful, this one is 4 minus 2. So e power I theta is what? Is cos negative theta plus I sine negative theta. Okay, cos power negative theta is cos theta, and then sine negative theta is minus. And remember, we still have got the bracket and the negative 2 outside. So when we actually expand, just be careful of the plus and minuses. Okay, and from there, okay, because we need to have the expression for C and S. So C is the real part. For real part, just take the real part lah. So this is our real part. Okay. For imaginary part, it's just this one without the I log, because we already say it's imaginary part ma. So we have got 2 sine theta. So for both of them, the denominator are the same. Okay. So that will be for the part 2. Okay. So that is for this question lah. Okay. Let's look at the next one. So first, solve the equation z power 5 is equals to 1. Write your answer in the polar form. So for this one, it's a standard roots of unity. Okay, the n roots of a unity. So this one, we are looking at the 5th root. So for this 5th root we actually have this one. Okay, z k is equals to cos of 2k pi over 5 plus I sine 2k pi over 5. So our k goes from 0 to 4. Okay, this one is quite usual. We have done this quite a lot already. Okay, so next part, okay, hence by considering the equation, okay, z plus 1 power 5 equals to z power 5, show that the root of this equation can be expressed in this form, okay, stating the values for the theta. So the first thing to do is we just expand this one and see whether we can get this exact same equation or not. Okay, but of course, this one we can actually get the same equation. Okay, which will actually end up with an equation which has power 4. So for this equation, we only have 4 roots. Okay, so next, how do we actually relate to the previous part is that what we need to do is we have to move this z power 5 down, okay, to become the denominator and factorize out, sort of factorize out the power 5. Okay, so what do we have for this one is that the solution for this equation, which end up with this one, okay, the values of the z inside here will be the value of the z for this one, because they are both related, but they are just expressed differently. Okay, so how do we actually solve this one is we just have to let the w, okay, to be the whole thing inside there, Okay, so we have W power 5 is equals to 1. And then what we need to do is here, we have got two things to do. Okay, one is because what we wanted, we want to have the roots, okay, for Z, okay, in this case not W. So because we already let the W to be this expression in terms of Z, we change the subject to be Z. Okay, so Z is 1 over W minus 1. Okay, so what is the value for this W? Actually, the value of the W here is actually what we have done in the previous part. Okay, just that we called it a different name lah. So basically, the roots comes from our part 1. So the roots from part 1 will have this form. Okay, so the angles or the theta there will be 2k pi over 5 I, and for that one, okay, the value of the k is from 0 to 4. Okay, but for this one we have got 5 values for the k, which gives us 5 roots, but cannot, okay, because remember this one is power 4, we only have 4 roots, so there's one root that we cannot use. So what is the root that we cannot use there? We can actually look at it from, because we are looking for the value of the z. Okay, so in this case the z cannot be 0. So when will cannot be 0 or it cannot be undefined. So when will this z undefined or be 0? So it is when our w is equals to 1. So now our w cannot be 1. So which value of the k that we have here will result in w is equals to 1. So the value is when k is equals to 0. Okay, so when k is equals to 0, our w here is equals to 1. So we cannot take that value. So at last, what we have is we have the z is equals to the w minus 1. So this is our w. Okay, our w is in this form. And the value for the k would be from 1 to 4, which is without the 0. So that we have 4 roots from there, which will actually be the solution for this 4 root for this equation with power 4. Okay, so okay, so I think basically that is it for the questions that we will discuss. Right. So if you have any question, you can kind of ask me later, because I think it's a bit not clear in the beginning. If you have any further question, you can come and ask me lah. Okay. All right. So that is it for today. So I'll see you in the next session. Thank you.